Hi, I'm Cheryl Leach. In this problem, we're going to be looking at the difference between delta y and dy. Let's take a look at a picture to begin. So I have 2 points plotted on a general curve. My input is x, my output is f of x. And then I'm going to move delta x units over and use the input x plus delta x, which then creates the output f of x plus delta x. Well, the first thing I'd like to consider is what's the change in that y coordinate? That's what I call delta y. Well, I notice that if I look at the distance from here to here, that will be f of x plus delta x. And if I look at the distance from here to here, that height is the same as the height going from my x coordinate up to my point. So that height will be f of x. This length right in here will be the difference, f of x plus delta x minus f of x. And that's how I define the change in y. So this is f of x plus delta x minus f of x. Well, how is that different from dy? Well, if you notice, I have a tangent line drawn at the point x, f of x. We know that dy dx is the slope of that tangent line. The slope is the change in y over the change in x. So that means that this distance, which represents my change in y, my change in vertical motion, that's the dy. The change in x is the dx. One thing that's kind of interesting to note is that dx and delta x are exactly the same. That's not true, though, for dy and my delta y. Another thing that's kind of interesting to note is that the smaller I take that delta x, the closer delta y gets to dy. Think about sliding this given point in so that it's right here. This will be my delta y, this will be my dy. Delta y was a much better approximation of delta y when the delta x was smaller. So that kind of gives you an idea of what we're talking about. Let's go ahead and do this problem. Right? I've already created a formula for my delta y. So I really just need to plug in the information for this particular problem. So we're going to have f of x plus delta x. In this particular problem, the x is a 1, and the delta x is 0.1. And then I'm going to subtract f of 1. This is really just function evaluation. So I'm going to have f of 1.1 minus f of 1. So I need to take the 1.1 and plug it in for all the input values in my function. So I'll have 0.5 times 1.1 cubed minus 0.5 times 1 cubed. Now there's some number crunching to do, but this turns out to be 0.6655 minus 0.5, which is 0.1655. So now I've calculated delta y. It's time to look at dy. Now if you notice, I didn't put a formula up for that one yet. But let's go back and remember what it was on my picture. I know that dy dx is the derivative. Okay? So that means that dy is the same thing as the derivative of my function times dx. All right, so let's plug in the particular information for this problem. The first thing I need to know is to figure out what the derivative of my function is. Well, this is a constant multiple and a power rule. So I have 0.5 times 3x squared. And now I'll multiply by dx. Now I want to know what's happening when x equals 1 and dx is 0.1. So I have 0.5 times 3 times 1 squared times 0.1. When I multiply all of this together, I end up with 0.15. Notice that my answers are very close. That's because dx is a very small number, and so dy was a pretty good approximation of delta y. I hope this was helpful. Thanks.